Next question that I want to go to is question number 5. I'm skipping 4. Question number 5 is that you have aeroplane flying across Australia. The Earth magnetic field acts 65 degrees to the horizontal. So you have picture being shown here, and has a strength of 2.7 to the power minus 5 Tesla. Induces an EMF between the wingtip of the aeroplane as shown below. The aeroplane has a wingspan. The distance from one wingtip to another is 59.5 meter, has a speed 270 meter per second. Calculate the EMF induced. So this is virtually a motional EMF. You have a piece of metal moving across a magnetic field of any source. You should induce EMF on the both end. Okay, same goes for the aeroplane. Another big piece of metal, you induce EMF due to the Earth magnetic field. So this is a portion that I want to highlight because this is a formula that you learn, BLV. Okay, so this formula is good to go provided that your magnetic field vector, the length and the V, if they are perpendicular to each other. If they are all perpendicular to each other, then this formula is good to go. Otherwise, if they are not perpendicular, you need to resolve. Okay, so now let me analyze this situation. Number one is that I can recognize that the wingspan over here, it is virtually a straight line. Okay, so I try to draw a straight line here. And then this length vector, you can think of it as a vector, is one horizontal line. So then what you need to do is to ask yourself, how about the velocity vector? So from this picture point of view, I want to say that the aircraft might be coming towards you or maybe away from you. I think you will agree with me. So from this position, I would say that if it's moving, it's either moving towards you or away from you. But maybe let me make one assumption. It is away from you, yeah? X means going in, away from you. If that's the case, that you have to ask yourself, is the velocity vector here, V arrow, is the velocity vector and the L, they are perpendicular. Okay, and if one is going in, one is horizontal, they are perpendicular to each other. I want to write like this. So this part is certainly good. But one thing is this magnetic field, however, you will see that there is not entirely perpendicular to the length. So what you need to do here is that this is the magnetic field and it's not perpendicular with the L. So what you need to do is you need to resolve this B upwards, vertically upward. You need to do so, yeah. And this one making the angle of 65. You need to resolve this B upward because only this position, this maybe call it BY, upward position, only this position would be perpendicular to the L, yeah. Because you see that L is here, then only will be perpendicular. So after some elaboration, I want to tell you that this equation here, you can only use it provided that if your B here being resolved such that it's perpendicular to the L. So to do so, this B here, if you want to resolve it, is that it is equivalent to B sine 65. So you want the opposite component. Okay, right now is that you want this component of BY, it is opposite of the angle of 65. That's why it's B sine 65. Okay, then only this component perpendicular to L, then you can write L and V subsequently. Now what you need to do next is that just now it is good to go for you to substitute the value. So this is the B, resolve vertically upward, and the length 59.5, this one no need to do anything with it, and same goes to the velocity, no need to do anything about it, and the final answer shall be about 0.393 volt. Okay, so this is the magnitude of the EMF. This is what I'm concerned about. I'm not concerned about the direction of the polarity is being stated here. It's not all my concern here. So remember in this question that the BLV, all three of them must be perpendicular to each other. Yeah, if you just use it without resolving, in this case, you will get it wrong. Okay, so remember that.